Hello students, welcome to online maths classroom. In this video, we are going to solve your miscellaneous exercise from question number 6 to question number 10. This is part 2 of the video, and in part 1 we discussed solutions of question number 1 to question number 5. Okay, so let us start. In this video, we are going to solve very important type of your problems, and they are called as transportation problems. Okay. So, firstly, we need to understand what are transportation problems. As you know, that cost is affected by the transportation. Okay. In this problem, we determine a transportation schedule in order to find the cheapest way of transporting a product from plants, factories situated at different locations to different markets. Okay. Question number 6 of your miscellaneous exercise is a transportation problem. Okay, so let us see what is a kind of transportation problem like. Okay, two godowns A and B have grain capacity of 100 quintals and 50 quintals respectively. They supply to three ration shops D, E and F whose requirements are 60, 50 and 40 quintals respectively. Okay, so two godowns are there. Okay, having their grain capacities. A godown is having 100 quintals and B godown is having 50 quintals. And these both godowns are supplying to three ration shops, namely as D, E and F. And these ration shops are having their own requirements. For D it is 60 quintals, for E it is 50 quintals and for F it is 40 quintals. Okay. The cost of transportation per quintal from the godowns to shops are given in the following table. Now this is your table given here. What does it means now? From D to A, the transportation cost is rupees 6. Okay. From your D to B is 4. E to A is 3. E to B is 2. F to A is 2.50 and F to B is 3. These are your DEF, the ration shops, and these AB are the godowns. Remember, how should the supplies be transported in order that the transportation cost is minimum? Everybody wants that the transportation cost should be minimum so that profit can be maximum. Okay. So what is the minimum cost? You have to find that your transportation cost should be minimum, and you have to find also the minimum cost for this problem. In transportation problem, we frame the information that is given in the problem in this form, okay, as per this diagram, and it becomes easier for us to frame the corresponding inequations. So let us understand how these diagrams are framed. So there were two godowns A and B with capacities 100 quintals and 50 quintals. Three ration shops which will be placing orders, D with capacity and requirement of 60 quintals, E with requirement of 50 quintals and F with requirement of 40 quintals. Okay. Now one who will serve first or go first will be having the benefit because it will get whatever it is desiring. And the second one who will go afterwards the first, it will only have whatever is left. Okay. So keep it in mind and then start framing the corresponding inequations. So let's say that this A godown has started supply with firstly with D, then E, then F. Okay. So let us see how these problems are presented and then how corresponding inequations are framed. So let godown A transport X quintals to shop D and Y quintals to shop E. Is it clear? We are starting with godown A transporting X quintals to D and Y quintals to E. Okay. And the transportation cost from the table, A is supplying to D at the rate of rupees 6 per quintal. Okay. A is supplying to E at rupees 3. Now the third ration shop F is left, and what it will get? It will not get the desired amount. It will get whatever is left with this and whatever it has sent to D and E. If we will take out the sum of both of them from this 100, only that it will be supplying to F. Okay. It is supplying from A to D X, A to E, your Y quintals. That means it has already supplied X plus Y quintals to D and E. Now its capacity is 100. So what is left with it? 100 minus X plus Y. 100 minus whatever it has already supplied. And only this is the amount, or this is the quantity which it can give to F. So it can supply to F as 100 minus X plus Y. Okay, as you can see that we started framing the problem from godown A. Okay, so every of the ration shop will be fetching maximum quantity from A. Okay, if you will start from B, it will start fetching maximum from this godown B. Okay, so as we started from A, so A will supply X to this, Y quintals to this, and remaining, that is 100 minus X plus Y, the sum of these two which it has already supplied, okay, to F, 100 minus X plus Y quintals. Clear? Please be careful about the sign. X plus Y, both are taken together to be subtracted from 100. Now let's come to godown B. Now godown B, what it will supply to D? Because D's requirement is X quintals, it has already taken from this. 60 quintals it requires. So what is the rest amount it requires now is 60 minus X. It just requires 60 minus X. Okay, so 60 minus X quintals it requires from godown B. Similarly, come at E, concentrate at E. E has already taken Y quintals from E. It requires 50 quintals. So what is its now requirement from B is 50 minus Y to complete both of them as to make 50 quintals. Okay, both of them added together will give you 60 quintals. Clear? Okay, I think it is very clear. Okay, 60 minus X, 650 minus Y from B to E. And now let us see what is happening to B to F. Now as it is the last shop and it is having from this interaction with now godown B, okay, which is also the second one because the first thing is already taken from A. So what is going to be happen now? 40 quintals it is requiring. It has taken this, okay. So that means 40 minus this complete. Please careful about the brackets. 40 minus this complete, okay. 50 was required, Y taken. So remaining 50 minus Y is required from here. X from here, 60 is total requirement. 60 minus X is supplied from B to D. Okay. So what will be supplied from B to F? Its requirement is 40. It has taken this quintals from here. So 40 minus this complete bracket 100 minus X plus Y is required. Okay. So when you will solve it, you will get X plus Y minus 60. I hope this is very clear. Okay. Now, how will I frame the corresponding linear constraints? Since the number of quintals transported to each depot must be greater than or equal to 0. X is greater than or equal to 0 and Y is greater than or equal to 0. As you have to order, okay, there are two godowns. What can happen here is that if A is supplying X quintals, this is supplying Y quintals, okay. So I don't know whatever is remaining which it is supplying to F, okay. Maybe what can happen is that B supplying to D, B supplying to E, some of the ration shop may have fulfilled its requirement from only one godown, okay. Maybe it is not having a requirement from the other godown, okay. So the basic thing is that whatever the problem is framed from here, whatever interaction is having between these ration shop and these godowns, everything what we got here is positive. X is positive, greater than equal to 0, Y greater than equal to 0, 100 minus X plus Y greater than equal to 0, this X plus Y minus 60 greater than equal to 0, 50 minus Y greater than equal to 0, 60 minus X greater than equal to 0. Everything is positive, greater than equal to 0. It is not like negative, okay, because business is going on, so nothing is less than equal to 0. Everything is greater than equal to 0, okay. And this is the transportation cost which will be framing your objective function. Now let me make it clear from this figure here. Objective function will be like 6x plus 3y plus 2.50 into this complete, plus 4 into this complete, plus 2 into this complete, plus 3 into this complete. And that sum altogether, whatever value we will be getting, will be the objective function of this problem. Okay. So as I explained, this is the first inequation. 100 minus x plus 5 greater than equal to 0. You will get 100 greater than equal to x plus 5, that is x plus 5 less than equal to 100. 60 minus x greater than equal to 0, x less than equal to 60. Similarly, from here y less than equal to 50, from here x plus 5 greater than equal to 60. Okay. Now as we need to minimize the cost of transportation, hence function used is minimize z. So this is the transportation cost. What I told you is 6 into the cost into the supply. So 6x plus 3y plus 2.50 into this complete plus 4 into this 60 minus x plus 2 into 50 minus 5 plus 3 into this x plus 5 minus 60. All together when solved will give you 2.50x plus 1.50y plus 410. I know it's not difficult and I explained how it has come. Okay, you can go back to the previous figure and can work it out. 6x plus 3y plus 2.50 into this plus 4 into this plus 2 into this and plus 3 into this. When all solved all together, you will get z as this. Clear? Now we need to minimize this subject to these constraints. Consider the corresponding equation x plus y equal to 100. x0, y 100, y0, x 100. See the less than equal to sign. So origin is satisfied, 0 less than equal to 100, origin satisfied, shading will be towards the origin and this is your corresponding line and shading is towards the origin. X plus y greater than equal to 60. Corresponding equation, x plus y equal to 60, x0, y 60, y0, x 60. 0 greater than equal to 60, origin is not satisfied. Shading will be away from the origin. So this is the line, shading is towards this side. Clear? Now see this, x equal to 60, the corresponding equation for this. And you know x equal to 60 means a line parallel to y-axis at a distance of 60 units from your this origin. Okay. And your y less than equal to 50, that is corresponding equation is y equal to 50 and the line is your parallel to x-axis at a distance of 50 units from here. Okay. Now origin checking says 0 less than equal to 60 is satisfied. Okay. Shading will be towards this side. And here 0 less than equal to 50 again is origin is satisfied, shading is towards this side. And this is the common feasible region we are having and transportation costs are bounded problems. Okay, because otherwise business is not possible if there are unbounded problems. Okay, so generally transportation problems are your bounded ones. Okay, so what are the corner points? 10, 50, 50, 50, 60, 40 and 60, 0. So let us apply the corner point. For 10, 50, Z is 510. For 50, 50, 610. For 60, 40, it is 620. And for 60, 0, it is 660. And we needed to make our transportation cost minimum. So it is coming out minimum 510 at point 10 and 50. Okay. Now let us see. While answering, you have to calculate whatever was transported from every ration shop from the godowns. Okay, to every ration shop from the godowns. So minimum cost is 510 and from A to D was X. So X is 10. So 10 quintals was supplied. Y is 50. 50 quintals was supplied. And from A to F was 100 minus X plus Y. Remember. So 50 plus 10, that is 60. 100 minus 60 is 40 quintals was supplied from E to F. Now from B to D, what was supplied? It was 60 minus X. Remember. 60 minus 10 is 50. Okay. From B to E, what was supplied? It was 50 minus Y. So 50 minus 50 is 0. That means nothing was, every whatever it required, this ration shop was collected from your A itself. So it doesn't require anything from B. Okay. But we have to work it out. So after solving, we got that nothing is needed to be transported from B. And for F, it is the remaining one, that is your 10 plus 50 minus 60. By putting these values, we will get 0 bundles. Okay, so only the first go down, actually which came first, will have the maximum orders, and whatever has come second will have the minimum orders. So not always you will get 0, but whatever value you will be getting, okay, it will come here when you will put the values of X and Y. Clear? So these are the supply from A 10, 50, 40 quintals to shop D, E, F respectively, and from B 50, 00 quintals to shops D, E, F respectively. Clear? Question number 7. An oil company has two depots A and B with capacities of 7,000 litre and 4,000 litre respectively. The company is to supply oil to 3 petrol pumps DEF whose requirements are 4,500 litres, 3,000 litres and 3,500 litres respectively. The distance in kilometer between the depots and the petrol pumps is given as in the table. Okay. So from D to A, the distance is 7 kilometer. From E to A is 6. You know how to read it. F to A is 3, D to B is 3, E to B is 4 and F to B is 2. Assuming that the transportation cost of 10 liters of oil is rupee 1 per kilometer, how should the delivery be scheduled in order that the transportation cost is minimum? What is the minimum cost? Okay. Now at last also you have to do something, that transportation cost of 10 liters of oil is rupee 1 per kilometer. This you will use at the last. Okay. So let us see how to solve it. And I think it is very clear. There are two depots again, A and B, and 3 petrol pumps DEF with their requirement and capacities. So let us go to let depot A transport X liters to petrol pump D and it transports Y liters to petrol pump E. Okay, and transportation cost for 10 liters is rupee 1. So that means for 1 liter it will be 1 by 10, that is 0.1. It's clear? Okay. Now as we are going to convert it to the cost, so let us work it out. As from D to A it was 7, so what will be the cost? It will be 7, okay, rupees 7 into 0.1, okay, 0.7. Similarly from E to A, 6 into 0.1, 0.6. From 3 into 0.1 it is 0.3. And this is for B. So from D to B it is 3 into 0.1, 0.3. From E to B it is 4, that is 4 into 0.1, 0.4. And F to B, that is 2 into 0.1 is 0. Okay. Now let us come to this diagram. It will make everything clear. Two depots AB, capacity is 7,000, 4,000. Requirement of 3 depots DEF, 4,500, 3,000 liters, 3,500. We started with transportation from depot A. Okay, it transported X liters, and this is the cost which we made by multiplying with 0.1. Okay. Okay. So let X liter is transported from E to D and Y from E to E. Rest you know. So what A is going to supply to F? It is its capacity minus X plus Y. 7,000 minus X plus Y. Clear? And this is the cost 0.3 from E to F. From B to D, its requirement minus what it has already taken. So 4,500 minus X. This is the cost. From B to E, requirement minus what it has taken. 3,000 minus Y. And from B to F, okay, what is that? Its requirement minus what it has already taken. Okay, so this will sort out as X plus Y minus 3,500. Okay, so since number of liters transported to each depot must be greater than or equal to 0. Okay, either it is 0 maximum as we got in the previous question, but we should take it as X greater than or equal to 0, Y greater than or equal to 0. Okay, non-negative constants. Now why non-negative constants? Okay, why will start asking for some requirement from some depot if you are assuming that I will not take anything from it. Okay, in the previous question also, that B was not knowing that it is not supplying anything to the last two Russian shops. Okay, okay, once its requirement was fulfilled, it came at the last, but the transportation cost was calculated and everything was calculated, and the values we got was on the basis of the inequations form. Now how do we frame the inequalities? You know it very well. Everything is greater than or equal to 0. Okay, so X greater than or equal to 0, Y greater than or equal to 0, this greater than or equal to 0, this greater than or equal to 0, this greater than or equal to 0, and this greater than or equal to 0 will give you these solve it. Take to other side. It will become x plus y less than equal to 7,000. It will become 4,500 greater than equal to x, or x less than equal to 4,500. Similarly, y less than equal to 3,000 and x plus y greater than equal to 3,500. Now we need to minimize the transportation cost. So how will you frame the transportation cost? Remember, it is this multiplication of this all together and this sum. That is 0.7 into x plus 0.6 into y plus 3.3 into this complete plus 0.3 into this complete, 0.4 into this plus 0.2 into this complete. And we will get the z as 0.3x plus 0.1y plus 3,950. Clear? Now we need to minimize this set, but we got subject to these constraints. So as per the table, for x0 by 7,000, y0 x 7,000, origin satisfied, 0 less than equal to 7,000, shading will be towards the origin. Okay, so this is your line, okay, and shading will be towards the origin. For the second one, 0, 3,500, 0, 3,500. So this is this line, shading is okay away from the origin, as origin is not satisfied, 0 greater than equal to 3,500. So shading is away from the origin. Clear? Okay. And these lines are x equal to 4,500 we will plot, and that we will line parallel to y-axis at a distance of 4,500. Okay. Less than equal to means origin is satisfied, so shading is towards this side. For the this one, y is 3,500, line parallel to x-axis. Okay. And shading will be towards the, as origin is satisfied, so towards the origin. Okay, towards the origin shading will be there, and this is the common shading portion. What are the points? 500, 3,000, 4,000, 3,000, 4,500, 2,500, 4,500, 0, and 3,500, 0. And when you evaluate this objective function on it, we will get the minimum is turning out to be 500 at 500 and 3,000, and which is a 4,400. Okay, so transportation cost will be minimum, as the values of x means A was transporting to dx liters, so it is 500 liters, then 3,000, and then 7,000 minus your whatever the inequations were. By putting the values of x and y, you can get this values. Okay, similarly from here, here, and here. Again, it came 0, 0 liters. Okay, and the minimum cost is turning out to be 4,400. Okay, so from A transported to D will be DEF will be 50, 3,000 at 3,500, and from B to these 3 to D will be 4,000, and then 0, 0 liters to petrol pump DEF respectively. Question number 8. Question number 8 of your miscellaneous exercise. A fruit grower can use two types of fertilizers in his garden, brand P and brand Q. The amounts in kg of nitrogen, phosphoric acid, potash and chlorine in a bag of each brand are given in the table. Okay. Tests indicate that garden needs at least 240 kg of phosphoric acid, at least 270 kg of potash, and at most 310 kg of chlorine. Okay. So there is a fruit grower who is going to use two types of fertilizer, brand P, brand Q, and the amounts of nitrogen, phosphoric acid, potash and chlorine, they are present in each bag, and the minimum requirement of or maximum requirement of these are as per that at least 240 kg of phosphoric acid, at least 270 kg of potash, at least means greater than equal to, and at most 310 kg of chlorine. At most means less than equal to, not more than it, 310 kg of chlorine. Okay. If the fruit grower wants to minimize the amount of nitrogen added to the garden, okay, so as vitamin A was there in your problem number 1 of miscellaneous exercise, it's like you're minimizing the amount of nitrogen. Okay, so there no condition for this at least or at most is given for nitrogen, so it will be the objective function. Okay, is added to the garden. How many bags of each plant should be used? What is the minimum amount of nitrogen added in the garden? I think the problem is very clear to you. So let bags of brand P needed be X and bags of brand Q needed be Y. Okay. Let us see the table. Okay. What does the table says? The table is brand. Two brands are there, P and Q. Number of bags, for P it is X, for Q it is Y. Nitrogen, phosphoric acid, potash and chlorine. It is given as in the table. And the total requirement for phosphoric acid, it is at least 240 kg, for potash at least 270, for chlorine it is at most 310 kg. Okay, and nitrogen is not given here as it is going to be the objective function. So let us see how the inequation will be framed. For phosphoric acid, brand P is 1 kg, brand Q is 2 kg. Requirement is at least 240 kg. That means X plus 2Y greater than equal to 240. For potash, from here 3X plus 1.5Y greater than equal to 270 at least. And 1.5X plus 2Y at most means less than equal to 310. Okay. So we got the inequation as X plus 2Y greater than equal to 240, 3X plus 1.5Y greater than equal to 270 and 1.5X plus 2Y less than equal to 310, and X and Y both greater than equal to 0 are the non-negative. Now we need to maximize the amount of nitrogen. So here the objective function will come from the nitrogen composition. Okay. So brand P contains 3 kg, brand Q contains 3.5 kg. So Z will be 3x plus 3.5y. Okay. And we need to minimize it. Subject to the constraints, these are the inequations we got. So the corresponding equation for this is x plus 2y equal to 240. When y is 0, x is 240, x 0, y is 120. See the origin checking, 0 greater than equal to 240, away from the origin. Okay, so origin is not satisfied, shading will be away from the origin. For this, 3x plus 1.5y equal to 270, y0, x 90, x 0, y 180. Again 0 greater than equal to 270, origin not satisfied, shading will be away from the origin. For third one, 1.5x plus 2y less than equal to 310, 0 less than equal to 310, origin is satisfied. So shading will be towards the origin. Okay. So we got the points as 240, 0 here, 0, 120 here. Okay. And 90, 0, 0, 180 here. And 620 by 3, 0 and 0, 155 here. So let us plot. Now let us plot the graph of these inequalities. For 3x plus 1.5y greater than equal to 270. And here students, we need to mention the inequation, not the equation, because this is not plotting of the lines. This is about finding out the feasible region. Okay. And feasible region will be decided on the basis of this greater than or less than signs. Okay. So we always write the inequations, not the equations. Equations are considered for plotting of the line. Okay. For preparing the table. As origin is not satisfied here, so shading is away from the origin. For this line, okay, this line x plus 2y greater than equal to 240, again origin is not satisfied, shading is towards this side. And this is the third line, 1.5x plus 2y less than equal to 10, origin is satisfied, so shading towards this side. And this is again a bounded feasible region with 3 corner points, 20, 140, 140, 50 and 40, 100. Using corner point method, we get the value of z as 550 for this point, for 40, 100 it is 470, and for 140, 50 it is 595. Okay, so number of bags of brand P are 40 and of brand Q are 100, and the minimum amount of nitrogen is 470 kg. Dear students, please pay attention to this table, as in question number 9 we need to maximize the amount of nitrogen for the same question. So from here table we can just conclude the answer. The maximum will be at this point 140, 50 and the value is your 595 kg. Okay, so let us see. The question is same, refer to question number 8. Okay, we needed to maximize the amount of nitrogen. How many bags should be added and what is the maximum amount of nitrogen? So we discussed it at 140, 50, 595. So number of bags of brand P are 140, for Q it is 50 and maximum amount of nitrogen is 595 kg. Let us see question number 10. It's a very important question. It says that a toy company manufactures two types of dolls, A and B. Market tests and available resources have indicated that the combined production level should not exceed 1,200 dolls per week, and the demand for dolls of type B is at most half of that for dolls of type A. If you remember, this is the same kind of question as was that of executive and economy class question that we discussed in our miscellaneous exercise part 1 video of question number 5. Okay, so we will see these lines and frame the corresponding equations. Let us read further. We understood that there are two types of dolls which a company is manufacturing, and they are A and B. Okay, and available resources have indicated that their combined production level does not exceed 1,200. So again, that was that not more than 200 tickets are reserved. So I got the first inequation is as x plus y less than equal to 1,200 if x is for doll A, and then for type B doll the value is y taken as, number of dolls are taken as y. Okay, and the demand for dolls of type B is at most half of that for dolls of type A. Okay, we will, while framing the inequation, we will keep it in mind. Further, the production level of dolls of type B can exceed 3 times the production of dolls of other type by at most 600 units. Okay, at most means, you know, at most means its maximum. Okay, should be less than it. If the company makes profit of rupees 12 and rupees 16 per doll respectively on dolls A and B, how many of each should be produced weekly in order to maximize the profit? So I think profit function is to be maximized, and it is very clear from here that I'll get the z as 12x plus 16y. So let us start the question, and the things or the conditions we got from here, we will frame the inequation and then we will have discussion on it. So let the number of dolls of type A are x and number of dolls of type B are y. Clear? So this is the table, dolls type A, type B, number x, y, and this is profit 12 and 16. So it is very simple, as the rest of the things are on that at least and at most conditions. So since combined production level should not exceed 1,200 dolls, so x plus y is less than equal to 1,200. It's very clear. Same as we have done that, not the total economy and executive class tickets put together should not exceed 200. Okay, same as in question number 5 of miscellaneous exercise. So x plus y is less than equal to 1,200 is your first inequation. Okay, now see this. This is very important. Also, production level of dolls of type A. Dolls of type A are taken as x. Exceeds 3 times the production of type B by at most 600. Okay. Type A means x. Exceeds minus 3y. It exceeds, so x minus 3y. By at most always means less than equal to. Okay. So we get the inequation as x minus 3y less than equal to 600. Type A is exceeding 3 times type B, that is 3 times y. So that means difference is x minus 3y. Okay. As you know that by taking the difference, if I'll take say 3y minus x, it will be coming out as negative. So the bigger one is x minus 3y less than equal to 600. At most means less than equal to. So this is your second inequation, number 2. And the demand of dolls of type B is at most half of that of type A. At most always means again less than equal to. So type B is your y. Okay, is less than equal to half of that of type A. Half means x by 2. So y is less than equal to x by 2. So cross multiplying, we get the inequation as 2y minus x less than equal to 0. This is your number 3. I hope it is very clear. Now we need to maximize the profit on dolls of type A is 12 and B is 16. So objective function is going to be z is equal to 12x plus 16y. So we need to maximize this objective function with respect to these constraints along with these x greater than equal to 0 and y greater than equal to 0. Let us plot the lines and firstly consider the equation x plus y equal to 1200. y0 x 1200, x0 y 1200. Origin is satisfied? Yes, 0 less than equal to 1200, shading towards the origin. For this one, okay, When y is 0, x 600, x is 0, y is minus 200. Origin is again getting satisfied, 0 less than equal to 600, shading towards the origin. For the third one, 2y minus x less than equal to 0. Now such lines are passing through the origin. Okay, so origin checking will not fetch any purpose, but I'll plot 2 points. So 0, 0 and 200, 400 are coming, and I'll plot this line like this. Okay, this is your x minus 3y less than equal to 600. Shading is towards the origin. For this one also. Okay, this is the line for x plus y less than equal to 1200, and this is for x minus 3y less than equal to 600. So shading towards this side, and for this shading towards this side. Okay, now this line again has divided it in two portions. So again I'll take a point here, and find which point is satisfying all the conditions. And definitely let us check it right now. Let me take one point from here as say 600, 200. Is it okay? 600, 200. So is 600 plus 200 less than equal to 1200? Yes. 600 minus 3 times 200. Y is 200. That is 600 minus 600, that is 0. Is it less than equal to 600? Yes, it is coming equal to, and for other point it may be less than. 2y minus x. 2y minus x means my point was 600 and 200. So 2 into y is 400 minus your x, that is 600, is negative and is less than equal to 0. And both x and y are positive. So all conditions are satisfied by a point in this region. You can take any other point also. So this is the required shaded portion. Closed one, bounded one. Okay. So let us apply the corner point method. And the corner points are 800, 400, 1050, 150, 600, 0 and 0, 0. Okay. So as maximum is needed, so need not plot the last one, but it's okay if you check it, that is also okay. So for 800, 400 it is 16,000. At this point it is 15,000. For 600, 0 it is 7,200. And the maximum we are getting at 800 and 400. Hence the profit will be maximum if the company produces type A dolls 800 and type B dolls as 400. And the maximum profit is coming out to be rupees 16,000. Okay, I think the question is very clear to you, and I hope you have understood the miscellaneous exercise part 1 and part 2. Okay, thank you.